Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 4 in the SSRF module, titled SSRF with whitelist-based input filter. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Go down, select the learning path. Go down, select server-side request forgery. Go down one more time and select lab number 4 titled SSRF with whitelist-based input filter. Alright, let's get started. This lab has a stock check feature which fetches data from an internal system. To solve the lab, change the stock check URL to access the admin interface at http localhost/admin and delete the user Carlos. The developer has deployed an anti-SSRF defense you will need to bypass. And the level of this lab is expert, so it's going to be a little bit difficult to complete this lab. Alright, so the vulnerable feature or the vulnerable parameter is the stock check functionality. And the goal of the exercise is similar to all the previous labs, which is to change the stock check URL to access the admin interface at localhost and then delete the user Carlos. Let's click on view, toggle word wrap, and here we go. And then let's create an analysis section. To access the lab, right click and open it up in a new tab. And in the meantime, I'm going to open up Burp Suite Professional. So you don't need the professional version of Burp to complete this exercise. However, I'm just using it so that I could use the render functionality, which makes it a little bit easier for me. All right, let's make this a little bit smaller and put it over here and go to the proxy tab. All right, so we've seen this application before and we know where the stock check feature is. So we're going to click on view details on any of the products. And we've got the check stock feature right over here. So we're going to set Foxy Proxy to send requests to Burp. And then we're going to click on check stock. And here we go. It was intercepted in Burp. Let's send this to repeater. Set intercept to off and work from repeater from now on. And we'll make this a little bit smaller so that we could see the response. All right, let's hit send to see what a usual response looks like. And you get the number of items that are in stock. Now let's do Control-Shift-U to URL decode it. And it looks like it's talking to an application called stock.weliketoshop.net on port 8080 and giving it the product ID in order to see how many items from this product type are still in stock. All right, so the first thing we do is try to access localhost. Let's hit send. And we get an error that tells us that the external stock check host must be stock.weliketoshop.net. So unlike the previous labs, it looks like the application is parsing the URL and extracting the host name and then validating it against a whitelist. And the whitelist has to be exactly stock.weliketoshop.net. So we won't be able to use the techniques that we used in previous labs, like putting in the IP address instead of the host name, so 127.0.0.1. That won't work either because it's not equal to this host name over here. Similarly, we can't do 127.1, which resolves to the localhost IP address. And we can't also use the decimal encoded version or the octal representation for localhost. So we have to get a little bit creative in a way that we could still insert our localhost IP address and trick the application in order to parse it instead of parsing the application's host name. So if we go back, again, let's URL decode this, Control-Shift-U. Let's remove everything from over here. And just add, let's say, username at stock.weliketoshop.net. So applications usually support this format in the form of being able to add credentials, and the credentials would be added before the @ sign. So it might be possible that this application supports that format as well. Let's hit send. And it says could not connect to external stock check service. That's interesting. So we're getting another error. Let's put a # sign to see if this is accepted. Hit send. And over here it says external stock check host must be stock.welikeToShop.net. All right, so although we do have stock.welikeToShop.net in our parameter, it still gives us an error as if it's trying to get an external system. And what that indicates to me is that it's viewing this as the URL instead of this. And that does happen depending on the URL parser that the application is using. And if you've never seen this before, it might seem a little bit odd, but depending on the language that you're using and the different URL parsers in the language that you're using, they might parse a string differently in order to find the URL. So what's likely happening over here is that the parser that this application is using is parsing this part first, and anything that comes after this part is automatically considered as a URL, and then whatever comes after the # sign is really just a bookmark, or you could think of it as a reference to an element in the page. So it's viewing this as the URL being username, which is an external service. And then within that external service application, it's viewing this portion over here as an element in the page. There's a really nice talk by Orange Desai, if I'm saying his name correctly, that explains how URL parsing works and how he exploited the different URL parsers in order to exploit SSRF vulnerabilities. And I'll link the video to the article in the description. All right, this is a really good sign. That means we might be able to bypass the whitelist defense and exploit the SSRF vulnerability. Again, what this is telling me is that it's trying to connect to username because it's seeing it as an external URL and it's no longer considering this as the URL that it wants to go to. So what we're going to do is URL encode this using Control-U and see if we still get the same error. And we do. Now let's URL encode it one more time using Control-U again. And see if we still get the same error. And we don't. All right, so it says could not connect to external stock check service. So we're bypassing another filter over here by URL encoding it twice. Now let's see if we give it a proper URL, if it'll actually connect to it. Because username is not a real URL, so let's say localhost. And it's on port 80. And we don't really need the 80 because that's a default. So let's just say localhost and hit send. And here we go. So we're definitely getting a response from localhost, which means that an application exists on the localhost IP address. So let's render. And we see the admin panel. So at this point, I know we're successful. The application is definitely vulnerable to an SSRF vulnerability. Now the next step is to access the admin interface and then delete the user Carlos. So let's make a few notes here. Let's copy this and say in order to access localhost, we use this link over here. We'll need that when we script the exploit. Next, we need to access the admin interface. So to do that, let's click on raw and check what the path is to the admin interface. So it's just /admin. So let's put that in here. What's happening over here is that the parser is viewing this as the URL, and then it's viewing everything after the # sign as an element in the application, and then everything that comes after the / is viewed as the path that you want to visit in this URL. So in this case, I want to visit admin. Let's copy this into our notes and paste it. Hit send and go to render. And here we go. We're in the admin interface. Next, we need to see what path is used in order to delete the Carlos user. So again, we're going to do a search on Carlos. And it's right over here. Let's copy that. put it in here. And before we send it, let's copy it and put it in our notes. So delete user and put it in here. And then hit send. And we get a redirection, which is a really good sign. So if you follow redirection, it'll try to get the admin page. However, it's trying to get the admin page through the external application, which is this one over here. And that's why you get an unauthorized. However, if you look at the admin page right now, so if we remove everything after admin and hit send, you should see that we've solved the exercise. The user was successfully deleted, and you no longer can delete the Carlos user because that user doesn't exist in the database. All right, so if we go back to our application, we should see a message saying, congratulations, you solved the lab. All right, so we successfully completed the exercise by exploiting the SSRF vulnerability manually. Now let's script it in Python. First, let's save this one. And as usual, we start first by importing the necessary libraries, which is requests, sys, and URL lib3. I'm also going to disable request warnings. So .exceptions, .insecure request warning. Next, I'm going to set my proxies variable. So what that does is it sets the proxy variable that is used for burp. And the reason I do that is because I want to send all the requests to burp. Just in case something goes wrong, I can debug the requests in burp. All right, we do the same thing for HTTPS. So 127.0.0.1 and again port 8080 and click on view and toggle word wrap. Perfect, that looks much better. And then we're going to define our main method. So if name is equal to main. Okay, and then let's create it. So def main. If the length of command line arguments that you use in order to run the script is not equal to 2, then I'm going to print a message saying that the usage instructions are as follows. So the name of the program and then the URL. Similarly, I'm going to print an example of how to run the program. And again, that would be the name of the program plus an example URL. Let's say www.example.com. Okay, and then we terminate the program because you ran it incorrectly. All right. So if you do run the program correctly, I'm going to take in the command line argument and save it in a parameter called URL or a variable called URL. And then I'm going to print deleting Carlos user. And I'm going to call a function called delete user that takes in the URL. All right, so let's implement this function right over here. So def delete user, and again, it takes in the URL. The first thing I'm going to do is create a variable called delete user SSRF payload. So that's a payload that deletes the user. And the payload is in our notes, so it's this one right over here. Let's copy it. Paste it in here. And what's going to happen is when you pass this through the request library, it will URL encode the entire thing. And this is double encoded. So what we're going to do is go back to Burp Suite Professional and do Control-Shift-U to remove the second encoding. So it's %23. Let's copy that and put it in here. Let's paste it. So what's going to happen is when this request is performed, this entire thing will be URL encoded, and this will be double encoded just like it was in our request. So we don't have to double encode it when it comes to the script, but we do when it comes to doing it manually. All right, and then we're going to create another variable called check stock path, and that's the path to the vulnerable page. We get that from over here. And then we want the params or the parameters of the request. And there's only one parameter in the request, and that would be the stock API. So let's copy that, put it in here. And the value of this parameter is the delete user SSRF payload. So we're just adding the payload that deletes the user over here. The last thing we need to do is perform the request. So let's say R is equal to request.post. We're using a post method because this is a post request. And it takes in the URL plus the check stock path and the parameters to the request. So data is equal to params. And then I'm going to set verify to be equal to false so that it doesn't verify TLS certificates, and proxies is equal to proxies so that the request gets sent to burp in case I need to debug it or look at it later. So what this will do is it will visit this page over here and it'll send this request that deletes the user Carlos. So the next thing that I want to do is check if the user was deleted. So I'm going to add a comment saying check if user was deleted. And to do that, we need to visit the admin page. So we're going to say admin page SSRF payload. And the payload would be this one over here. So similar to what we did over here, in order to confirm that we got this message user deleted successfully, we needed to visit the admin page. So the payload is this one over here up until admin. So let's copy that, put it in here. And then we need another params2 variable. And again, it's stock API, except in this scenario, the value of the parameter is admin page SSRF payload. And then we're going to perform the request. So request.post URL plus check stock path. And then it's pretty much the same from here on. So params2, and then verify is equal to false, and proxies is equal to proxies. Okay, this looks good. The next thing I'm going to do is check if Carlos is not in the response text. So r.text. If it's not, that means the attack was successful. So I'm going to print successfully deleted Carlos user. Otherwise, I'm going to print the exploit was unsuccessful. Let's save that. All right, so what's happening over here is I visit the admin page and then I check if Carlos is in the response. If Carlos is in the response, that means the user was not deleted. However, if it isn't in the response, that means the user was deleted, and so the attack was successful. All right, let's save this, go to terminal, new terminal, and run our script. So that would be Python 3 SSRF lab 04.py and the URL of the application. And it likely timed out, and it did. So what we're going to do is generate a new instance of the lab. All right, it loaded up. Let's copy it and put it in here. Paste. And if you look over here, we already include the slash before the path, and so we need to remove it over here. All right, hit enter. And here we go. It says, congratulations, you solved the lab. So we successfully deleted the user. If you go back to burp and go to proxy HTTP history, you should see the requests that the script made. So if you go over here, first it made a request that deletes the Carlos user, and then it made another request to the admin page in order to see if the user was deleted. And I'm noticing over here it's saying invalid external check URL. So we made some kind of mistake over here, and I'm not sure what it is. So if we look at this, it should be HTTP. Let's save it. However, this passed because Carlos was not in the response. So that's something to keep into consideration when you're checking if something is successful or not. So let's hit enter. Let's look at the post, and here we go. So if you click on raw and check if Carlos is in there, it's not. And then if you render it, here we go. Carlos is not on the page, and so the user was successfully deleted. All right, so we successfully completed the exercise by first manually exploiting the SSRF vulnerability, and then we scripted it in Python. In the next lab, we'll look at how to combine an open redirect vulnerability in order to bypass SSRF defenses.